Welcome to my talk. We are starting to dive into the wonderful world of web development. There will be a few more talks about that. I'm Moritz Duge. I'm working at Allotropia since half a year. And I'd like to take you into a journey about WebAssembly and all around that. So a little bit about where we started from. So a lot of people are using LibreOffice to help with their business applications. It's a public administration, but also the private sector. They tend to have very specific use cases where they do things. I just need to get my notes up here on the screen. Yeah, there they are. Stuff like somebody's going to the administration, wants to get maybe a fishing license, or a company does a contract renewal for customers, and forms need to be filled, data needs to be exchanged, and documents need to be generated, and basically those organizations try to map their processes somehow. I guess it's a good thing for them if they can automate their stuff themselves to a certain level, because it keeps them flexible when they change their processes. They don't need to put out a contract so somebody else develops something for them, but they themselves can change code, can change the automated processes, and that's basically something where Office suites are wonderful for, because you have many great features you can use. You have all the flexibility with the macros, with APIs. You can do a lot of templating, creating form letters, and so on. Basically, Office software is basically some kind of low-code platform for those companies where their own staff can do basic tasks to automate things. So that's where Office suites are really great in. So problem is nowadays, since already like 10 years, much stuff is migrating into the web. And we don't have like one-to-one classic Office suites there. Most Office suites somehow moved into the web, but especially when you look at Google Docs or Microsoft Online, you have to stick to their APIs. It's not common to run that on premise on your server, but you're completely bound to their infrastructure to use that. And the alternative would be to find other ways to do your tasks, to go completely away from the existing workflows you have, which use Office documents and macros and things like that, to adopt to JavaScript libraries you have never used before. So that also would be a lot of work. So the nice idea is to use LibreOffice, what customers already use for those tasks, and just to find a way to move this into the browser and to integrate it with the web applications you already have there in the browser. Kind of what some people already do on the desktop for a long time, like integrating Office software. I know also of cases where that's happening with Microsoft Office, but also for LibreOffice, where that's integrated into a bigger application. And the idea is to be able to do this in the web, and just to have the Office software, in some cases, just as some kind of library working in the background, helping generating documents, which are, and the data is being put in somewhere else in the bigger application. We've been working in that direction at Allotropia for quite some years. Thorsten and some other colleagues gave nice talks about that. In 2021, we showed how we can basically run a LibreOffice process in the browser via WebAssembly. So WebAssembly it came up in 2017, I think. And it just basically enables you to run something like native code in the browser. I'll talk a little bit more about that later. And you'll find that in the Document Foundation wiki. So there's a page about WebAssembly and how you can run LibreOffice basically in the browser with WebAssembly. But if you do that, it's really capsulated in that WebAssembly world, and it's very hard to interact with that. So in the past year, we put a lot of work into bringing this really into the JavaScript world and make it feel like it's a JavaScript API you can leverage, like a common web developer leverage its other JavaScript libraries for building web applications. So the advantage is doing it that way and not running some server application, some LibreOffice on the server. It basically boils down to these things. You need a static web server, which is very easy. You can just use some static content delivery network or something like that, where you put in your LibreOffice binaries and they just get delivered to the client, to the web browser. Then the application runs fully inside that web browser, so you have very low server load. We got the size of those files being served via HTTP. We got it down to 32 megabytes for the actual application binary, plus 15 megabytes of data like graphics and stuff. And yeah, we have ongoing work there. We hope we can reduce this much further down, having an even smaller file which needs to be served. But already yet it's quite fast, especially because the files have become small enough so the browsers like to cache them. So browsers typically don't like to cache big files, so you can just fill up the cache of a client serving your website with stuff it might not fill the hard disk with. Yeah, so but those sizes are small enough for the browsers to cache them for a long time. And yeah, the end goal is what I just already described a little bit, to have something like a JavaScript library, which feels like really natural to use in a JavaScript application. Yeah, I make a little digression about JavaScript. Yeah, this also, I think it's nothing everybody encountered when working with JavaScript. So usually for JavaScript, everything runs in the usual case, like in something called the main thread. So that's just one context where the instructions get worked one by one. And if you want some parallelization, you need to use a feature called web workers, which is basically actually more like processes if you think in terms of operating system terminology. So those web workers by default have no shared memory. You can use a construct called shared array buffers. So those allow you to have shared memory between those web workers. But even then, for example, you can't access the document object, which is like the object in the main browser thread, which represents the actual HTML page. So you need to access that to manipulate the HTML page. And so there are certain barriers when using that. Yeah, and I'll come back to that later. Yeah, surely you have some way of passing information. That's the support object, which the browsers give you, where you can exchange information between those web workers. But it's not the same as threads in an operating system. Yeah, so I come to a little bit of examples for the code we have written. So yeah, this is just like basic JavaScript. So just to show this as an introduction, what's happening there. So this is just standard stuff to get an element from the HTML page. Interesting thing is here this FS object. So that is an object which is created by Emscripten, which we are using to bring LibreOffice into the browser. So the Emscripten environment creates a kind of virtual file system in the environment where LibreOffice is running. So LibreOffice can expect to interface files in the way it does when it's running on a normal operating system. And this kind of virtual file system can be accessed from JavaScript. And what we are doing here is we're getting a file which is being uploaded on the HTML page. And then we are putting it into a file in this virtual file system. So next step, this is just a few initialization stuff to get some basic variables, like the standard API which LibreOffice has to program it externally or through macros. And there we have a few objects from this context. And then we can use those objects, and this is now something we have to do in the respective worker. So in the background, Emscripten, the environment we are using, started some of those web workers to reflect the threads which LibreOffice expect to expects to create from the operating system when it's running natively on a system. So mscript needs to reflect that somehow, and it's using those web workers for that. So kind of every web worker represents a thread, and you get to pick the web worker where the actually main thread of LibreOffice runs, and then you can basically do normal commands. So this is not a lot here. Didn't want to pack too much on the slides, but basically this is just normal commands. And there you tell LibreOffice, hey, load this file from the file system. LibreOffice doesn't even know that it's a virtual file system. It just sees, yeah, there's really a file, temp file. It's loaded, and in this case, we do nothing else than to store it again on the disk, but then as a PDF file and not as an ODF file, what it was before. So, hey, we have converted a document. Okay, switching to the demo now. Yeah, there it is. Okay, this is just a very basic demonstration where we show that we can interact with the HTML world outside there. And what's happening here is I need to move my mouse cursor over. Okay, that worked. And now I can upload a file. So, and what's happened in the background is we are calling that, first thing is what I just showed you, the file is being put into that virtual file system. Then we are calling the API, telling the API to convert the file back to a PDF, store it back to that virtual file system, and then we are back in the normal JavaScript context, and the JavaScript just reads the file out of that virtual file system and puts it into the standard Chromium PDF viewer. So this is not LibreOffice itself you're viewing here, this is just Chromium displaying a PDF the way it normally does it. But hey, we have successfully converted an ODF to a PDF in the background with the full capabilities of LibreOffice. Let's see how much time I have. There's some time left, so I can do some more demonstration. It's just a little difficult here. Should have mirrored my screen. Okay, what we can do now, the document, it's still loaded in the background of the LibreOffice process. The process still has the document opened, and we can, for example, use to make modifications to the document. So in this case, this is simply calling the document, getting a cursor in the document, and then telling the cursor to insert a new string at the top of the document. So then we have that string in the document. We can't see that yet, but I'll just execute that command. So, next thing is to tell LibreOffice to store the modified file again on the disk. And what I now do is I could change actually the web worker context in Chromium. So up here, there's a little thing in the Chromium debugger. Firefox has something similar where you can tell the browser in which of those web workers you want to execute JavaScript commands. So I could switch back to the main web worker thread. But instead, we also have some infrastructure here in this demo where we can just pass a message to the main thread. So I can just tell the main thread, hey, I have changed something in that virtual file system. Please read it again and put it back into the PDF viewer of Chromium. And there it is. We have changed the document. Now at top, we have that extra string. Yeah, so a little bit more about the challenges we had with the underlying technology. So everything is still pretty new. We have the WebAssembly technology basically. So WebAssembly is like, before that, basically web browsers, the language all web browsers agreed on which they can execute. So the Turing complete language was JavaScript. So everything had to be JavaScript when it needed to do Turing complete stuff in the browser. They finally agreed on some standard which is called WebAssembly. It's similar to what Java did many years ago. So it's a kind of virtual bytecode format. And yeah, also comparable, for example, to what Python does. You may stumble upon those PYC files Python creates, so that's also some kind of intermediate code. So that's not bound to a certain CPU architecture. It's very like generic. You can execute it quite fast on every kind of CPU architecture. And yeah, that's actually the WebAssembly standard. Then we have this mscripten environment. Mscripten is basically for compiling C and C++ application to WebAssembly, or for the compiling itself, it leverages Clang, but it kind of wraps the C application in an environment where you don't have to change much in the application to get it working in this world, like the virtual file system I told you about. Yeah, and finally we have those web workers. That's all still pretty new to the web browsers. There's still ongoing work. And yeah, there were a lot of challenges with that. One thing we stumbled upon is where I was really going like, what the fuck is happening here, is when I read that there's something happening with CPU vulnerabilities. So I know in 2018 we had those CPU vulnerabilities where a lot of CPUs, Intel, AMD, but also ARM, were hit by, where you can sniff on other processes and things like that, Spectre and Meltdown. And yeah, for me, this was basically a thing the operating system had to care about, or maybe I get a BIOS update where the microcode of the CPU gets patched and then my system is less vulnerable to this. And I read that there's also something going on with web browsers. Actually, back then I assumed you can hack the operating system from inside the web browser because of Spectre, one process can hack another one. But it turns out that's actually not the case. It's kind of even worse. Because what happened here is the web browsers, when they run JavaScript code, they have like the JavaScript engine, which runs the JavaScript code, and a web browser usually turns up multiple instances of that JavaScript engine, even for one page you're viewing, for one tab. Because in one tab you have content you load from different domains, from different origins. Maybe you load some JavaScript library from somewhere else. And those stuff from different origins gets executed in different JavaScript engine environments by the browser, but it's happening in one process. So one browser tab is usually one process for the operating system, and all the operating system cares about when it comes to the Spectre and Meltdown vulnerabilities is to restore the process isolation. So that was the guarantee everybody expected before Spectre, that one process can't access another process. And that's what the operating systems like repaired, and what the processor vendors also tried to patch with BIOS updates. But yeah, here kind of the web browsers do its own kind of context isolation inside one process, and that's nothing the operating system can help anything about. So yeah, the web browsers were left to themselves and had no great way to fix this. Yeah, and to be a little bit more clear about what I'm talking here, it's basically stuff like cookies, for example. Like cookies hold very important authentication information. If you get the cookie for somebody's online banking login, yeah, you can access this bank account. That's basically the information the web browser tells the banking server, like, yeah, I'm an authenticated client, I can do some interactions. And you could steal that from another JavaScript context. Yeah, so that's basically a problem here. And to nail it a little bit more down to the technology, I come back to that shared array buffers I talked about before. You need them to share memory between those web worker processes. And in the end, the web browser vendors decided you can only use shared array buffers when you agree to certain restrictions about loading stuff from different origins. So what I said before, when you have one browser tab where stuff gets loaded in from different origins, yeah, like a picture from one origin and a JavaScript library from another one, and then your own code from your origin, and you mix that all together, then you have to agree to certain restrictions when you want to use shared array buffers. And that's basically, you can't run LibreOffice without using shared array buffers, because without them you can simulate something like threads. So for running LibreOffice, you have to agree to those restrictions. You have to configure your web server to send some headers, which tell the web browser that it's okay to agree to this restriction. But the biggest problem is other web servers may have to agree too. So if you load content from another origin, you can only do that if the other origin also agrees to that. And if you don't have control over the other origin, you basically can't do that. So that's still a very, very strict restriction. I won't go much more into the details here. If you want to look into that, look for those words I wrote there, like cope, coep, quelp, and that. Yeah. Besides that CPU and shared memory stuff, it's also just that yeah, as I said before, WASM was released in 2017. It's not so long ago, but there's still a lot of ongoing development. Chromium is typically leading that. Firefox is catching up pretty fast on Chromium usually. Safari is a little bit what used to be the Internet Explorer in the 2000s. They are always a little bit behind, and yeah, sometimes you have to use some quirks to get it running in Safari, or the restrictions there are about that same origin policy I just talked before. They are even stricter in Safari because they didn't implement some newer standards which Firefox and Chromium have to get around that. Yeah, mscript in itself, it's been released in 2012, but back then it was actually more like a transpiler compiling C and C++ to plain JavaScript. ASM.js was there in between, which fastened up that a little bit. But yeah, it adapted to WASM then after 2017. And there's actually a lot of ongoing work. We pushed a few patches upstream. Stefan did some great work there. I also just a few days ago pushed the patch where you can actually see the web worker name here. So before that, like all the web workers were named the same. They were all named EMP thread 1, no, EMP thread without number. So I just added a patch that you even have a number there so you can see in which web worker you actually are when you debug something. Yeah. So, that's pretty much what we have been working on in the last time. Next thing we are planning to do is we want to improve, like we want to have basically the LibreOffice view itself in the browser. As I said before, some time ago, Thorsten already presented where we showed like the full LibreOffice running in the browser, but it was hard to interact with. So now we are working towards having like a small widget where you can just see that part of LibreOffice that you want to see, usually just the rendering of the document. You want to have that, and so you can fit that into other web apps. First idea would just be to replace the LibreOffice controls for the document, like the toolbars, with some JavaScript stuff, which gets rendered outside of that LibreOffice view. So you have nice JavaScript controls for that, or HTML controls. Yeah, and next thing to make it really feel great in the JavaScript world to use that is also to integrate it into frameworks like Vue.js and AngularJS, which are very common in the JavaScript world. So you just get a nice experience and using it like just any other JavaScript library, and not something coming from a foreign world you maybe don't know so well when you are a web developer. Yeah, so thing will be even that you can react to events. So when there's something happening in the LibreOffice, like the user is typing in letters, you can react to these events from your JavaScript code and do something with it. And you just, if you edit something in the document, like I did in the demo, edit some string, you just see that live in the LibreOffice views you have there. You don't have to convert it to a PDF and throw it into the Chromium PDF viewer or something like that. So we are very actively working on that, and current plan is to show that next month on the SFSCon in November. We're making some pretty nice progresses there. And just to show you some idea we have there on the last slide, I have prepared a mock-up for you. So this is something we are thinking of, like you have a customer database in your web application, and there you pick a customer, and then you just say insert the address of the customer, and then you have LibreOffice here, where you have some letter template, and it will just insert the address data of the customer into that letter, and that's something where we think that's a really great thing if we can get that working. And yeah, as I said before, see you at the SFSCon next month. I guess we have some great progress made then. So, any questions? Yeah? So Collabora is really great when you want to get away from Google Docs, just when you're editing documents together with some other people, like collaborative editing. But what we are doing is for integrating LibreOffice into bigger applications. So that's something which is very common in organizational environments like public administration or private business, where you don't just run an office on your desktop and edit some files, or you run just Google Docs, but you have other applications which, like I show here, provide address data, and you want to integrate that. Any other questions? For the WebAssembly binary. Oh, that's hard to scratch that together from my memory. Where, as I said, there's a lot of ongoing work in Mscript, and there's ongoing work also in Qt, and we are using a lot of patches we have written for those. We are trying to get those upstream, but for the moment we have own builds of Mscript and Qt to get in all those nice additions, like what I just showed you with that named web workers. That's a lot of stuff we do. We also do some compression, and yeah. Good question. I'm not sure. I can do it on this notebook. It has 32 gigabytes of memory. I haven't tried to decrease the memory. What happens then? Yeah. Okay, so yeah, I guess pretty much time is up. So thank you for your attention.